And not the worksheet correlating to the video, but just in the overview of Module 8, do you recommend, I think it said to go through and write where each module, where it talks about those items in each module, and is just to be able to refer to it more quickly. Is that correct?
So we've covered, for example, Module 1 here, right? In Module 1, there's notes for Module 1. You could actually go through and say, okay, Module 1.1 objective was covered on page 4 of Module 1 notes. Or on Module 2, calculating N in percent of frequencies, that was on page 3 of the Module 2 notes. So you should be able to tell when you're answering the questions what they line up with. So if I'm asking you to, talk about, standardization, or if we're looking at types of distributions, or if we're talking about, different types of data or a z-score, you should be able to then go to this list and go, okay, that's in Module 4. And then, how we do this is Module Objective 4.9, and that's on page 12. That's just I don't know how you study best. But just trying to help you sort of line up when you see these things. So like if you go here to this module, this is the worksheet that goes with the video. We have, variable types here that in the video for the worksheet that says what variable types are these sodas, or, what's soda, what's age, what's weight, what's sex. Well, Module 5, let's talk about variable types in research questions. So we see variable types talked about in Module 5. We see variable types talked about in Module 1, so that you can recognize some keywords and then go back to these objectives and say, okay, we talked about predictor and outcome variables in Module 1. Well, these are asking for questions about predictor and outcome variables. So I can go back to my notes in Module 1 and that will help me.
Okay, thank you. That makes sense.
I have a question. So when, like you said, the Google document for the exam, we open it up. So is it the same day you have to answer the quiz?
Nope, you have a whole week.
All right, okay, perfect.
So you have 1 week. There's no time limit other than the week. The exam itself will open up this Friday at 8 o'clock in the morning, and it's due at 5 p.m. next Friday on July 3rd.
Okay.
But the reason, again, just to make this clear, that this has been set up like this, is that you don't have to do it in Canvas. You don't have to sit with Canvas open. You can print out these questions, download the data, pull up the data code book, and read this paper. And you can do all of this on your own with your computer. When you are ready, when you feel like you've answered all these questions, then just open up the midterm exam and answer them in Canvas.
Thank you.
Just don't submit in Canvas. Like if you open it up, don't submit it until you're ready to submit it.
Okay.
Because you only get one try on this. There's no like, I didn't do this well, I want to go back and fix something. This is open, enter, submit.
All right, got it. Thank you.
And you've got, if I may ask again, you can hear me okay, can't you?
Yep, sure.
Probably better than you wish. As I'm looking at Module 8, it says midterm exam spring, and then it says midterm exam summer at the very bottom.
It's summer. I just forgot to change it.
Okay.
Yeah,
So,
don't worry about it.
So there's no time limit.
Nope, no time limit. You don't have to worry about, but that's what I'm saying is that you have a week to do it.
Yeah.
You have a week to do it. So just don't open the Canvas part, the enter, like where you enter in the answers until you're done. And then just open Canvas and enter them and submit it. Everything you need is right here to do the exam. And then when you're done with it, when you feel like you've answered all these questions, just open this, put them into Canvas and submit it.
I guess my question is, what's the difference between the first entry, BST 610 midterm exam spring and midterm exam summer? What's the difference in the two of those?
This is just misnamed.
I understand that.
The questions are exactly, so this is a Word document.
Right. I understand that part.
This is a Canvas quiz.
And that's to work your problems.
So
So
you will
this-
use this, and this to do the exam. When you feel like you've answered every question on this Word document,
Right.
come back here and open
Okay.
this Canvas quiz and transfer your answers.
I got it.
Okay?
So to actually submit your submission occurs under the final option there, midterm exam summer 2020.
Yep.
That's where you submit it. Okay, very
Yep,
good.
that's where you submit it.
So is any penalty in downloading the questions to think about them before we start the process? I mean, is it open right now? You
Nope,
said
it opens on Friday. Everything
Friday.
opens this Friday,
okay.
and then it's due next Friday.
Okay.
So you have 1 week, open book, open note, to work all the problems
Right.
and open this up and submit them. You have a whole week. So all of it will open up on Friday at 8 o'clock in the morning, and everything will close next Friday at 5 p.m.
Very good.
Other questions?
Looks like the Word document's open right now. Is that correct? The one that says spring?
Is it? It's not
the,
supposed to open until, is it June? Is today the 24th? Yeah, it opened this morning. Sorry. Yeah, it opened this morning.
Oh, I got you. Okay, very good.
I gave you guys a couple extra days.
Very good. Thank you.
I was thinking it was Friday for some reason. But yeah, this stuff's all open today. So you can go in there and you can get started now if you want.
Very good.
It's just,
I have a question about Learning Check 7.
okay, hold on 1 second. Let me just change this here. Okay, Learning Check 7. For correlation.
Yeah. Maybe my mind is not right or what. I could understand the video. It was amazing. And only thing where I am getting a little bit tied up is the question where you've said, right, like you did one reagenda age by your hand, like 1, 2, 3, and then you teach us how to do if and else, like adding if and else. So I did first part. I don't know how to do it, like 1, 2, 3 in the first part of it. So if you question.
Is that in Learning Check 7 or is this a question in Module 7?
It's a question let me check it in my Learning Check. I don't know how to do it. I just don't know how to, I could understand the video, but I don't know how to practically do it on Jump.
Okay, so I don't know what you're asking me to do. So if you can find it and point me to the right like the right spot.
Sure. This question 13, right? Like question
Okay.
13?
Okay, 10, 11, 12, 13. Oh, so, okay, so this is just a different way to recode things. Let me, hold on 1 second here. Okay, so let me just pull up a different data set here so that we can sort of take a look at the way to do this without doing it in the actual data. Okay, so what it's asking you here to do, let me get rid of that data, is if we take our continuous age, right, and then put people into age groups, we want to know how many people are in that age group. Do you understand that?
Yeah.
Okay, so this is just a blank data set here. This is just that test data. So we'll do it a little bit, we'll just create some different categories. But the first thing I want to do is take a look at my age distribution. And for this particular data, I have an age range from 18 to 32. So let's say I want to put my 18 to 19-year-olds together, and then I want to do my 20 to 22-year-olds, or my 20 to 21-year-olds, and then I just want to do 22 and older. So that's similar to what this question is asking you to do in Learning Check 7, right? It's putting them in 3 groups here, 16 to 18, 19 to 65, and 65 and over. In this particular data, we can create a new column. I can call this age groups. And then, so you can either recode it, right? But in long data sets, recoding that many is going to take a really long time. So the first thing you want to do is do a formula. And edit formula. And you get this blank formula window in JMP. So I'm going to go under conditional and say if. And now I'm working on my age variable. So I want my age variable to be in this little blue box. And I know that I have 18 to 22-year-olds here, right? That's what I saw in my distribution. So I can say if age is less than or equal to 19, because my first bin's gonna be 18 to 19-year-olds. So if their age is less than 19 and I start with a quote, and I can put in 18-19. And you don't need to do the end quote. JMP's already got it there for you. If you type in the end quote, it's gonna yell at you a little bit. So you just have to do the start quote. I typed 18-19 and I press enter. So that's gonna get my first group of ages into the 18 to 19-year-olds. Now I need two more options here. And to do that, I just use this little caret that's up here, this insert. And I'm gonna hit it twice. Hit it twice and that gives you another level. This middle one is different because I need it to be in between two things, right? So I need age to be in between two areas. And if I go over here on the left side of my formula, I have two options here. Since I've used the equal sign for 19, I can use the greater than sign here. So I'm gonna put 19 there, and I'm gonna put age here. And I'm doing this because less than or equal to 19 is already up here. And so now this next row, I want to start with those ages that are greater than 19 and less than or equal to 21. That's my next category for this one. And then the same thing here. I start with a quote. That tells JMP I want it to be a categorical variable. And I can type in 20 to 21. Remember, I don't need to do the end quote. Press enter. And then in this case, with this data, everybody else is going to be 22 plus. That's my else statement. I've already looked at my distribution. I don't have any like missing, I don't have any weird data. So I can simply just put everybody else as 22 plus. Press return. So now if I just press apply, you can see over here in column 6 how that all changed. And I can press OK, and I can press OK. And here's my new age group variable. The one thing you want to do is you always want to check that it worked. Always want to check that it worked. And there's lots of different ways you can do that. You can use the tables menu and do a summary and put both age group and age in here. And so then I can check that all my 18 to 19-year-olds are in the 18 to 19 category. My 20 and 21-year-olds are in that category, and everybody that's 22 or older is here. That's the summary menu. You can also do a fit Y by X. And I can put my age groups as my X factor and age as my Y. And you'll see I'll get our familiar ANOVA figure. But really all I want to do is look at to make sure that my 18 to 19-year-olds are only 18 to 19, and my 20 to 21-year-olds are only 20 to 21, and then my 22-year-old 22 plus or 22 plus. So you always want to check when you recode something to make sure that it worked the way that you want it to work. So being satisfied that this worked, that I've got my 3 age groups now, I can do a distribution here. And now I can see that I've got 9 individuals that are 18 to 19 years old, 28 individuals that are 20 to 21, and 22 individuals that are 6. So for Learning Check 7, you have a much larger data set, but you're basically doing exactly the same thing. You're trichotomizing the data. You're making it into 3 groups. You're going to follow the same steps, only your formula is going to be a little bit different, right? Your formula is going to have different age cutoffs because you're working 16 to 18, 19 to 65, and then over age 65. And then you do a distribution and put the numbers in.
Perfect. Thank you so much.
Sure.
That was super helpful because I think the video that was it Dr. Austin did,
Yes.
She utilized a different way and didn't show us how to do 3 groups. I think it was just 2.
Okay.
So that was very helpful. Thank you.
Yeah, there's lots of different ways to do lots of things in statistics. And everybody programs a little differently.
This is very, very easy compared to what I was like. I spent a lot of time figuring it out, but it was super, super helpful. Thank you.
Okay, sure. Other questions on LC7?
When you got ready to change the groups, what did you click? Did you just right click the column
To do what?
to get the box to
the
enter in all the
formula?
information?
Oh yeah, so to do the formula. So again, there's more than one way to do this in Jump. You can go to the columns menu and you can ask for a new column and that'll give you a new column. Or you can just double click to the right of the last column you have and it will also give you a new column.
Okay.
And then you go under column properties and formula.
Okay.
And then you want to edit formula and it'll bring up the formula box.
Got it.
Mm-hmm. So in your data set that you guys have, I mean, it's also possible that you could just do a sort. So tables sort, I'm going to sort by age, and it's going to bring up a new data set, and now all my ages are sorted. So I could simply type in 18 to 19 and change it to categorical, and I could cut and paste it as well, right? So you don't have to do a formula, but you do need to make sure if you're going to do it this way that your data is sorted and that you save this data set once you've sorted it so that you can go back to it, because it won't change your primary data set. See, I don't have any age groups in here. So once you sort it, if you want to do this is like brute force manner, you can do it this way, but I don't recommend that because then now you've got 2 different data sets and get rid of that one. Okay, other questions on creating formulas? Ding dong. I wonder how many noises they went through before they picked on the doorbell for Zoom. Okay, next question.
Okay.
If nobody else has, I have a question about question 11 and question 14
Okay, question 11.
and question 14.
Okay, so after conducting the appropriate statistical test, what can you conclude with regard to the association between age group and total cholesterol? So using this test data again, we've got in here, I have age group and I have systolic blood pressure. So that would be similar to having age, right, and total cholesterol. And now I've created my age group, right? And I've got systolic blood pressure. So if I have a categorical X, something that's in categories, and a continuous Y, what analysis is that? So if I go into fit Y by X, and I have a categorical X and a continuous Y, what does that get me?
Linear. Would it be a linear? Would it be a linear correlation?
I somehow managed to mute myself. So it's asking me, what can I conclude with regard to age group right? Age group, so that's categorical, right? So that's here. And I have a continuous Y, that's here. Which one is my X factor? I'm asking, anybody?
X is the
The age group.
Yep, so age group is my X factor. And then what would my Y be?
The total cholesterol.
Right, and in this case, that would be systolic blood pressure.
Yeah, sorry.
And so what analysis does that give me?
A one way. And we're
Yeah, it
gonna
gives
do
you a
t-test.
one way. It gives you a one way. And if I press OK, you're going to get this figure that looks like this. So if I only have two groups, what analysis is that?
A t-test.
Yes, two group t-test, TTT. Two group t-test. And then if I have three or more groups, what is that?
ANOVA. ANOVA.
I like this choir that I have. Yes, ANOVA. It's ANOVA. Right? So you'll just ask it for the appropriate relationship. So that's what you do here. If you've got age group, and then which is categorical, and you've got total cholesterol, which is continuous, it's either going to be a two-group t-test if age group is in two groups, or it's going to be an ANOVA if age group is in multiple groups. Okay, you guys want to see my interpretive dance for statistical tests?
Yes.
Absolutely.
Very helpful. It's very helpful. So I've shown this to somebody on the call already, but you guys will get to see it too, because it's kind of, it will help you remember, I promise. Okay, so if we have a continuous variable, right, we estimate the mean, correct?
Yeah.
Okay, so I'm the mean. This is me just sitting here in the middle. Now I want to know if, everybody pay attention, group 1 and group 2 are different. What shape is that?
T.
It's a T, right? It's a T. I want to know if the mean for group 1 is different from the mean for group 2, or if I just need one mean. There's my interpretive dance for, am I one mean or am I two means? Okay, now I don't have enough arms to do my interpretive for the F test, but I can draw it for you. I know it's sad, I need another arm. Okay, so again, continuous outcome, here's my center line. This is my mean. And now I have three groups. 1, 2, and 3. An F test is basically going to compare group 1 to group 3. And if they're not different, then there's no difference, right? Because if 2's in the middle somewhere, who cares? Right? So it compares, that's basically what the F test is asking. Do I have one mean or do I have multiple means? So that's the F test. And then if you get real fancy on the way you draw your F, you could put feet on it if you have 5 groups. But that's how you can remember t-test or F-test. Two-group t-test, TTT, two-group t-test. And then the F-test has the 3, if you cross your F's all the way, then you've got 3 arms that are sticking out from the mean on the F-test. Is my interpretive dance helpful?
That's very good.
It was very helpful.
Yes, you'll see when we get to a 2x2 table, which you guys have all seen before, right? In our 2x2 tables, you'll also be able to remember what test it is, right? So here's our 2x2 table. And it turns out we do a chi-square test. So we do an X test where we look at the corners. So that's chi-square test or an X test. So I doubt these were what they had in mind when they designed them, but I find it's easy to and very helpful to remember. Okay, so that takes care of question 10 and 11. So let's go down to question 14. So again, now 10 and 11, we had 10 put into 2 groups with a continuous outcome. So 2-group t-test, TTT. And 13 puts us into 3 groups with a continuous outcome. So that is what?
ANOVA.
Yeah, that's an F test and ANOVA.
Right.
And do we need to write, like they say, it's like be sure to include all the relevant information. So just write that it has 3 groups, etc., etc., just definition.
So you've seen some written summaries,
Mm-hmm.
right? So when it's really helpful here that we kind of, not in Learning Check 7, but in Learning Check 6,
Mm-hmm.
if you go back to LC6, let me get there. We've walked you through already in LC6 what the appropriate information is, because you actually entered each
Mm-hmm.
part of it, right? So you said, like, there's this many categories. That means I'm doing this test. Here is my hypothesis. What's the alternative hypothesis?
Mm-hmm.
What's my alpha level? What's my P? What's my determination? And then here's the sentence. And then
Right.
here's the statement.
Mm.
So LC6 broke down what you needed to write into separate questions.
Mm-hmm.
In LC7, you're going to put it together in a paragraph.
Right, got it. Thank you.
If you think about, and so this plays into the paper that you read for the midterm, for the final 3 questions in the midterm. You should be able, since you know how to do this, you should now be able to look at research papers and pull out the appropriate information, right? If you can write this paragraph and you know how to write a null hypothesis, how to write an alternative hypothesis, how to do the analysis, how to get the p-value, and what decision to make, when you read a paragraph in another paper, you should be able to visualize what their data looks like. And you should be able to pull out the parts in their results that associate with these parts. Because now you know how to do it. It'll also be really helpful in figuring out when people do things wrong. So you have all the steps in Learning Check 6. And then in Learning Check 7, you're going to write a paragraph that includes all those individual answers.
Just to clarify, so I already did mine, and I obviously don't want to give like anything away, but I, in my paragraph, just had said something similar, like we were looking at this, we have evidence to, either evidence to show that it varies by this or doesn't vary by this, and then I gave the information as far as like F, DF, all of that. Do we need to also specifically state like this was the null hypothesis, this is the alternative hypothesis, or is that sufficient?
That's one way to state it, is like, here's my null, here's my alternative. You'll find in research that we don't actually ever say that. It's not that explicitly done. So as long as it's clear in your conclusion, right? So we have evidence to suggest that, or we have found that we have different means, or we have statistically different. Our favorite saying is there's statistically significant difference. So as long as it's clear what you've chosen, like what's your statement, either we did find them to be different and here are the means, or we didn't find them to be different and therefore the overall mean is, whatever that is. Like, as long as you're clear about how many groups you had, what the mean values were, is there a difference, and then what's your evidence to support that difference?
Okay, thank you.
Sure. You guys will find that we do a lot of work, statisticians, to be included in the parentheses. That's like, this is, that's the evidence. Like, it's, you just can read, when you read papers, you just see parentheses with p-values. And now you know what goes into getting those p-values.
I have a question.
Other questions?
I have a question.
Sure.
As far as when you said how many groups you have, when you put that in, is that supposed to be in parentheses as well, or just prior to stating, we have evidence or we do not have evidence?
Well, so you need to tell me what you're comparing, right? So you wouldn't just put in a research paper under results, we have evidence to suggest we have different mean total cholesterol. By what? By different means for what? You'd have to say by race, and you'd have to give the racial categories. Or we've found, I mean, gender is a really easy example because most are only including 2. And so it's, there's a statistically significant difference between males and females, or males are higher than females. Like, use your words, don't use your variable names. So somebody should be able to read your paragraph that doesn't have this data, that doesn't know this exam or the learning check, and understand what you did. Like your conclusion. They should be able to read that and say, oh, they found that there's a statistically significant difference in total cholesterol values by race, and that the African-American race has this mean, white has this mean, and other has that mean, or by age group or whatever.
I have a question about the in the population statement.
Mm-hmm.
And I'm looking for it, but I can't find it. But it was one, I can't remember if it was on the notes. I think maybe it was on the notes when it said you don't use in the population. It was like only one example, I believe. So on Learning Check 6, were we supposed to mention in the population when we stated our results?
Yeah.
Right. Okay.
You don't generally see the words in the population. What you'll see in a research paper is that they define the population. And then they'll say something like, we found that there was statistically significant evidence that this treatment is effective over this treatment in persons with relapsing remitting multiple sclerosis that are that are 18 to 65 years old, that have had the disease. Like, they'll define the population.
Okay.
On the midterm exam, when you read the paper in Ethiopia, there's a question about what's the population. So it asks you have to read the paper and you have to determine what is the population. So really think about, we take a sample from the population, we do statistics, and we use that information to infer back on the population. So really think about who that refers back to when you read that paper in the midterm. Also, don't freak yourself out about this. I know it's hard because I'm the teacher, and I know all the answers. But you guys you've really done all of this. The only difference here is that you have different data.
Mm-hmm.
And so the steps, like, there's nothing on this midterm exam that you haven't done already multiple times. And if you think about everything you've done so far, we've determined what kinds of variables we have. We've determined how to summarize them. It's either n% or it's mean, median, 5-number summary, right? Those are our options for the continuous. We've looked at a 2-group t-test. We've looked at an ANOVA, and you've looked at correlation, right?
Mm-hmm.
That's it. That's all there is. I feel like there's a song like, that's all there is. Yes, that's all there is. So now you just have to pull it together in one, like, start to finish analysis. Other questions?
I do. In terms of rounding, I remember you saying at one point to not round our numbers.
Don't round to an integer. So you don't want to have 14.4 and round it to 14. You want to say 14.4.
Okay. Round to integers.
And then your p-values, when we ask you for exact p-values, that's the 4 decimal place p-value.
Okay.
When you get further along in your research and in your paper submissions and that kind of stuff, what you generally see is non-significant p-values are usually left at 2 decimal places in publication because it saves space. You don't need 4 decimal places to tell somebody something's not different. And then significant p-values will be to 3 or 4 decimal places, but that's generally dependent on the journal. In this case, for this class, just always report your p-values to 4 decimal places. you get 4 decimal places and jump, just report 4 decimal places, because that tells me that you've pulled the correct p-value and you didn't actually just kind of like happen to guess the point, you know, and don't write that it's bigger than 0.05 or less than 0.05, because that tells me you didn't get a p-value and you just guessed. Like, actually do the 4 decimal places. And then when we're talking about summarizing, say, age, so this is a good example here, age or systolic blood pressure. So if I go in here and I do, let's look at age, gender, and systolic blood pressure and my 3 age groups. So when we're talking about summarizing things, I don't need to report 20.5814 as my mean age, because this is years, that's months, that's weeks, that's days, that's seconds. We don't need to know the seconds of age, right? We really just like age is 20.6. You might use 2 decimal places if you're talking about like toddlers, because that's like months and weeks, like that might be useful. But then you'd probably switch to talking about weeks or months rather than talking about years. So, you know, you meet those moms, the new moms, and you're like, oh, how old's your kid? And they're like 14.5 months. And you're like, okay, well, 1 was fine. Like, you could have told me 1. But in statistics, 1 decimal place is usually sufficient. Same thing with the blood pressure here, right? I mean, this is fake data. You would never, so nobody would ever report a blood pressure like this. You could report 114.6. So just be specific. And then when we're talking about proportions, you want to report, you know, 30.2% and 69.8%. Oh, another, she really likes our Zoom calls.
Oh yeah, she's been in here the whole time.
And then, you know, 20.9, 65.1, and 13, it would be 14.0. So because this is a double rounder, right? This goes up to an O, but still report 14.0. Don't report 14. Other questions on that? Oh, does she have like rainbow unicorn hair? So cute.
I have a quick question.
Sure.
Can you explain that rounding again? So you said don't round to the next whole integer. So if it's like 14.985, whatever, you would just keep it at that first decimal. You wouldn't round it to the next whole number.
Becomes, yeah, so if you're looking at something that is, let me just pull up a blank doc. So this happens all the time and it's really annoying in statistics, right? So if you're looking at something that's, get rid of this stuff here. If you get something that's 14.98765, this is going to get rounded to 15.0.
Okay.
Don't leave it at 15. It's 15.0. Statistics is about being, you know, as specific as you need to be. And so it's important to have 15.0. If you have something that's like 35.5 and 55.5, that's fine. But if this is like 5.9 and 5.7, then you're going to end up with 30. Oops. Oh, FedEx is here. I wonder if I got something exciting. I probably didn't get anything. You know, this becomes 35.6, and then this would become 55.6. Or sorry if I can type correctly. So just, you know, try to keep things to 1 decimal place, unless you like really need 2 decimal places.
And that includes when we're reporting our statistics, when we reject or fail to reject our hypothesis. So like when we put like F equals, you know, keep it to 1 decimal.
Yeah, so you can use 1 decimal place or 2 decimal places on your F-test or your T-test.
Okay.
You'll want to use 4 for the p-value for the purposes of this class.
Yeah. Okay. Thank you.
Yeah, you just don't want to round up your F like your F or your T to an integer. Because of the way that p-values are calculated, you know, you'd get a much different p-value for a 2 than you would a t-test of 2.0 than you would for a t result of 1.59. So you don't want to round that 1.59 up to a 2, because that wouldn't match your p-value.
But if it was a 2, then it would just be 2.0 and not
Yep,
this.
it would be 2.0.
Okay, great. Thanks.
Mhm. Anything else? All right, well, I'm here till the top of the next hour, so if you guys work and have other questions, you can just pop back in.
I have one about, it's an older one about the recoding of the race ethnicity on the RBS.
Yep.
In order to get the same numbers that she got on the video, I had to leave the missing blank.
Uh-huh.
But sometimes when we recoded with you for categories, didn't we just type it in?
Right, so that's a super good question. When do you report missing as missing, or when do you just exclude them, right? Yeah, so this becomes a larger theoretical discussion. When you are just reporting how the question was answered, right? So we had 444,197 responses. It's important to say how many people didn't answer race. That's informative. But when you're doing statistical comparisons, I'm not going to compare the missing race group to whites because I don't know what the missing are, right? So when I'm doing a statistical comparison, the missings will get excluded because I don't want to have an ANOVA comparing black, white, and missing. What I want is a t-test comparing black and white.
Okay.
So it really comes down to the question, like what is it that you're trying to report? Are you reporting the percentage of people that didn't answer the question because that's important? Which it can be. I've got a study right now where there was a data collection issue and we've got 57 people that we don't know their gender. So we actually need to report that and say that, we don't have gender on this percentage of people. For all analyses, including gender, those people will be excluded. Because I can't tell you anything about their results by gender because I don't have their gender.
Right.
So it just depends on what you're asking.
This was just the first time that since we've been recoding that I had to actually leave it blank.
Yep.
And so I was just trying to figure out how could I get the same numbers that she was coming up with. And yeah, it was a little bit confusing, but yeah, thank you.
But you figured it out, right?
Yeah, but it makes me kind of afraid, for like a test or something to know if I'm going to have the same numbers when I'm recoding.
So on the exam, when you get to the parts that are free, like just be clear about what you did. That's why, like in Learning Check 7, when you're asked for that paragraph, you have to combine all, you wouldn't just say, oh, we found the means to be different. Because I would say, what mean? What groups? How many are in the groups? What are the groups? Was anybody missing? So you have to be clear about what you did. Is that missingness informative? When you get deeper into statistical analysis, you talk about informative missing. So if you think about, again, we're on like a little bit of a tangent here, but if you think about income value, right? When people are asked their incomes, there's it's usually about 20% of people that say, I don't want to answer. I prefer not to answer on income. And they're generally the people in the upper income level. So like studies have done that. Like if you say 150 plus, so we did this, we tested this in a different population and a group of people. We had a question that we ask every 6 months where it goes up to 150,000 and the next checkbox is 150 plus. Then we ran a sub-study on insurance coverage and we explained that it was really important to know what their income was to assess the amount of medical care that people were paying for out of pocket and how impactful that was. But it was the same group of people. And we were able to show that the people who checked I prefer not to answer when it was just 150 plus, or they just checked I prefer not to answer, were actually in the upper income categories, right? And so it again goes back to your question, and it also goes, this is like moving forward and you all are designing your own data collection instruments. Be very specific about leaving options for people to say, I don't want to answer this question, because them telling you they don't want to answer it is not the same as it being missing, right? If they just skip it, you don't know, did they just skip it or did they not want to tell me? And so sometimes saying I prefer not to answer is very informative. One, it helps you figure out that they actually got to the question, that there wasn't some kind of error in your data collection instrument or it wasn't skipped. And two, it tells you about your population in terms of like what questions are people like, do they not want to provide you information? And race is a tricky one. You should always have an I prefer not to answer on race. Or if you actually need, if you're really talking about, especially when you get into genetic situations or like multiple sclerosis, African Americans tend to have more progressive disease. Relapsing remitting tends to be more Northern European. And so when we're doing things like clinical outcomes or the way that the drugs work, it's actually really important that we know what people's race is. And so sometimes you have to explain to them, like, please don't skip this question. Like, I understand that culturally, or like this may be a difficult question for you to ask, or you don't think it's important, but we're telling you, like, we need to know it. We have that problem with sexual function questions as well in multiple sclerosis. A lot of people feel really uncomfortable answering those questions, but they're actually really important. Like, how can we make it better if you don't tell us that you're having an issue? So for the purposes of this class, just be clear about what you did in your paragraph. And, I'll read them. I grade your midterms, so it's not the TAs, it's me. I tend to be a little more flexible.
Okay, thank you.
Mm-hmm. Anybody else?
Hi, this is Marla. This is maybe a really dumb question.
Yeah,
but
if you don't know the answer, it's not a dumb question.
Well, I know the answer because I got the grade. So.
Well, but if you didn't know
So on one of the assignments, I think it was the one that we turned in as a group, I thought that it was an enrichment assignment. So I made the decision. It was one of those times where, I had a lot of stuff to do at work and everything. And I made the conscious decision to not turn that assignment in because it was enrichment credit. And I thought it was not a graded assignment. And then I thought that in the office hours for that week, you said, oh, you can choose to turn it in or not.
Yep.
But it will help you with your group study and so forth. So I had a 0 on that assignment and it was definitely graded. So
right, but all the enrichments, that don't worry about the scores for those. Doing them, when you do the enrichment credit, that all gets counted at the end of the semester. So
okay, that makes sense.
The 0 on enrichment, so Canvas has some issues with the gradebook. I've set it up such that the enrichment points are not going to be in your grade. They're counted towards 0% on Canvas. Because if you don't do it that way, it's going to come into your overall grade and Canvas will do it wrong. So do the enrichment credits. They're good for you. But if you don't get any points on them, or if you do it incorrectly or you skip it, it's not going to hurt you.
Oh, okay. I understand. And I definitely have to do them. It helps. But just that week, I couldn't. I just ran out of time.
That's fine.
But yeah, thank you so much.
Not doing them doesn't hurt you.
Got it.
It's a double negative.
Also about the enrichment credits, if we got everything right and we report just like how it's associated with whatever our interest is or whatever, how do we really write that? Just write, you want to see like paragraph, like a 1-page paper or something like that, or do you really just want us to go through each question and say how it pertains to our background or whatever we're interested in?
I don't know what enrichment one you're talking about specifically.
So I know at the bottom it said like if you got everything right on the enrichment on the learning check. I'm sorry, on the learning check.
Yeah, okay.
Then just go in and just write about it. Just tell how it's part of like whatever your interest is or anything like that.
Yeah.
So I just really want to know how you wanted it.
I want you to reflect on it.
Mhm.
It's hard to say what that, like how you associate with assignments. It's hard for me to put myself in your shoes. But you know, reflection and reflecting on how you got the right answer is equally as important as to like how you got the wrong answer. So if you got everything right on the learning check and you go back and you reflect on it, you can say, well, I determined that these were statistically different because, and tell me why.
Okay.
It's not just that the p-value was significant, like actually reflect on what does that difference mean? How big was it?
Okay.
What's the implication there?
Okay. Got it.
Yeah, remember statisticians, I can tell you a lot more than that, but statisticians, we basically tell you where differences are. As the researchers or as the people with the disease interest, it's really up to you with our help to interpret it. If I, again, large enough sample size, I can find anything to be statistically significantly different. That doesn't mean it's meaningful. So it comes to the interpretation. I did a study once for our emergency department here where they were trying to figure out how long people were waiting for emergency services. And there were a lot of things because they had a year's worth of data. I mean, that's thousands of emergency department visits. And so we were getting a lot of stuff that was statistically significantly different, but it was only, this one variable would statistically lower the wait time for people, but it was only lowering it by 3 minutes. And to make the change, it was going to cost the hospital $200,000. They're not going to make that change. 3 minutes isn't really a big, isn't a huge wait time for a non-critical case. And so, it involves this indicates that you could improve this, but is that improvement worth the cost, right? So that was the larger discussion. Other questions?
Just one more. I came in late, so I don't know if you've discussed it yet, but as far as the midterm, you were saying that we just go into module 8 and print it out, or?
Let's go back to module 8. So yes, you'll be able to go back and watch the beginning of this video because I really go into it in depth.
Okay, well, if you did.
But I can run through it just real quick again as a quick review. So module 8, let me close up module 7 here. Module 8, the overview has what we've done, and there's a video, and there's this worksheet. If you fill out the worksheet when you're watching the video and you want the correct answers, just submit it before next Wednesday. And when you submit it, I will give you the answers. I'm not going to grade your worksheet, but I am going to return the answers back to you on SpeedGrader. So I'll just upload where you ever get your comments and your grades. I'll upload the right answers. These 4 files, 1, 2, 3, 4, are available now. These are the questions on the exam. Ignore that it says spring. I just forgot to change the title of it. These are the questions for the exam. This is the data set for the exam. This is the code book that goes with the data set. And this is a paper that deals with the last 3 questions on the exam that you have to read the paper and then answer some questions about it. It's available now. You can ask questions up through next Thursday. It's due next Friday. Once you've answered everything on here, open up this Canvas quiz and transfer your answers from the Word document to Canvas. You are not going to upload this file. You are going to input your answers into Canvas. So it'll grade the multiple choice ones automatically. And then I will grade the free text questions. And it's due by next Friday at 5 o'clock. I recognize that next Friday at 5 o'clock next Friday is a UAB holiday. That's why you got it. It's available today. So if you want to get it done before next Friday and start your weekend early, huzzah. And I'll tell you guys that there is no material next week. I've already released it. It's module 8. And then the following week is midterm review. So you guys can actually have a weekend if you want to have a weekend. Next weekend, not this weekend. This weekend you should work on the midterm.
Dr. Cofield, so I finished the quiz already for this week,
Mhm.
and I have a question from it. It's not related to the quiz. I just had this question when I was taking it.
Okay.
Okay, so the quiz is basically asking you to conduct different analysis, and then it's asking that you want to redo your analysis because of the misleading. It can be misleading from the previous analysis you conducted. So I was wondering, okay, so if you conducted a correlation analysis and then you're like, maybe the data is misleading, I need to conduct more analysis, different analysis, and you group the variables, and then you conduct t-test or ANOVA like the demo ask you. So the result shows would just be like, well, there may be variances, like there's statistically significant variances within this population. So what does that tell you about your previous correlation analysis? I don't understand why we would want to like conduct further analysis to telling us there's variance between these two groups. What is that? Okay.
So let's think about it this way.
Mm-hmm.
One, you want to investigate your data set very thoroughly. You don't want to just get an answer that you like and stop looking.
Right.
Right? And say, oh, okay, we're good. When you look at a t-test, an ANOVA, or correlation, they are answering different questions, right? It could be the same. So if I think about a t-test, right, and I just cut the age at 65,
yes,
and I look at a mean, if that's statistically significantly different, all it's telling me is that I have a different mean cholesterol for people under 65 and for people over 65.
Yes, exactly.
That's not very specific, right?
Mm-hmm. Yeah.
And also not surprising,
mm-hmm.
given what we know about cholesterol.
Yes.
Right? So the next step is, well, let's take my ages and make them a more fine, like, so now we're going to switch it to 3 groups, right? And we're going to do the 18-year-olds and then the 19 to 65 and the 65 plus.
Mm-hmm.
So, and then it tells me I have a difference there, right? Now I know more information.
Yeah.
Right? So now I know that not only is there a difference in cholesterol 18, like 65 and older versus 65 and younger, now I know that there might be a difference between the 65s and older and the really young people, but those that are like middle age and 65 aren't that different.
Mm-hmm.
That's helpful. Then I want to look at age as a continuous variable versus cholesterol as a continuous variable. And what that answers for me is, for every 1 year older in age, what do I anticipate cholesterol to change?
Mm.
That's a different question than is cholesterol different by age group. The correlation to ask me, as age gets older, as people get older, what happens to cholesterol and by how much does it change? So I could say for an 18-year-old versus a 20-year-old, what's that change?
Mm-hmm.
The t-test or the ANOVA doesn't tell me that.
Mm-hmm.
It just tells me that the mean for people that are under 19 is this value. It doesn't tell me that if I am 12 versus 21, what's the difference?
Yeah.
Remember, because as soon as I put people in groups, I'm treating them all the same.
Mm-hmm.
So anybody under the age of 19 is treated the same. Doesn't matter what their actual age is. When I do a correlation, I'm looking at the individual ages.
Okay. I guess I'm just confused by the reasoning stated on the question that, so it says that the relationship from previous knowledge, you know that relationship between age and total cholesterol may not be linear, and you decided to do this new analysis. So does this new analysis tells you whether it's linear or not?
So linearity is assessed by looking at your plot.
Mm-hmm.
Let's pull this up here.
But from it, we kind of know the answer already about the linearity after you conduct analysis. Why is it asking again that from previous knowledge each may not be linear?
Right. So replicability is really important in science.
Mm-hmm.
But you also have to always look at your own data.
Yes.
So in the general population,
Mm-hmm.
there might not be a linear relationship between age and cholesterol. There might be a point at which you get like basically a hockey stick, right? There's a linear relationship here, and then past a certain age, it's a different slope.
Yeah.
So it's like a different thing. That's fine. Like you might
Okay.
want to try to find the apex point. You might want to try to find where it changes. But you always have to look at your specific data, because within your sample, linearity might be okay.
Oh, you know what? From like where the question was going, I was thinking that maybe in later on you will want us to separate the groups and then conduct correlation analysis within each age group, but you didn't. So I was like, oh, okay.
Yes, but you're thinking ahead.
Okay. Oh, really?
Right.
Okay.
Yeah, you're thinking ahead. That's good.
Okay.
So, right, this is in this test data. Here is age and systolic blood pressure.
Okay.
And like this is, fake data. But linearity is assessed by basically looking at this plot. And there's more ways to do it. And we have 2 whole semesters called linear analysis in the doctoral program in biostatistics.
Cool.
There's like tests and stuff for it. Like there's theory behind it. But basically you want to know, is there like a line fit? Or is there obvious curvature? Right? And so if there's obvious curvature, if there is, if it looks like I can draw, a lot, this won't let me do it. If it looks like I can draw, a shape, then linearity is probably not okay. And then correlation doesn't matter. Like, oh, she disappeared. It's like Harry Potter. Then linearity there she's back. You're like one of those disappearing pictures in Harry Potter movies. If linearity is okay, and if you want to know, in this density ellipse that you fit, if 95% of the points are within this circle, then bivariate linearity and normality is probably okay, as long as you don't see like an obvious curve. And by the way, a flat line is still a line. So if you don't see a pattern, like any obvious pattern that has curvature in it, then linearity is probably all right.
Okay, this may be a dumb question, but what's the difference between T statistics? I know like T statistics and Z statistics are different in terms of different tests we have to conduct on JUMP, but what exactly is the difference? So
that's a really great question. A Z statistic assumes that we know the variance, that it is a known entity, like that we know we have this specific standard deviation. A T distribution is going to estimate your standard deviation from your data.
Okay.
So the Z and the T will have the same mean, but they'll have different standard deviations. The curve is flatter. The bell curve is flatter in a T. It's wider because we have more standard deviation. We never know the true variance. We don't ever know it. We always use our data to estimate it, which is why we do t-tests. Like z-test is just a simpler place to start. That's where our theory started. That's what the bell curve or the standard normal was invented first. But the t-test is what we use in practice because we always use our data to estimate our standard deviation. So we're just a little bit less unsure. So the curve becomes a little flatter and a little wider. That's it. That's the only difference.
When we mentioned that correlation analysis is a robust statistic, what does that mean?
It means it withstands, it's robust to outliers.
Okay.
So in this particular one that we look at here,
as long as 95% of the dots is within the line, we're good.
Robust means that even if I have like this outlier and that outlier, that the test is still going to be reliable.
Okay.
That it's robust to departures from normality is what we say. That's the statistical term for it. To do this, we're assuming bivariate normality. You said if they're within that ellipse, that's how we look at it. And so it's fine. So I can fit this line, right? And I get a p-value of 0.082. And let's say I exclude this big outlier here and I redo my analysis. And I look at my fit statistics. They haven't really changed that much. Like my fit's still 138.4 minus 1.12. Now I'm 135.4 or 1.1 as well. Like that one outlier didn't really do a lot.
Okay. I
So
see.
it's robust and it's still not statistically significant. The results. So it's, that's all that robustness means. And if you want to think about, I think of all crazy ways to like, those big air suits that you put on that like make people look like a giant marshmallow,
Yes.
right? So you can like throw stuff at those and it'll bounce off,
Oh, okay. I
right?
see.
It's robust to like rocks being thrown at it. But if you take me out of that bubble, those rocks are going to hurt, right? It's like,
Yeah.
just robust means that you can withstand some slight departures from your assumptions.
Okay. Okay, Dr. Colville, I still have questions. I was just pausing to
Okay.
see if people have other questions because I don't want to keep
Okay.
asking. Okay, so when we were talking about the ceiling effect, the effect on the BMI,
Mhm.
it didn't come intuitively in terms of how was the ceiling effect produced in the first place? What happened that there's a ceiling effect, causes that ceiling effect?
All right, repeat your question again.
Okay, so I was looking at the demo, which is they're comparing age group to BMI or height to BMI. I don't remember actually.
Yep.
But there's a ceiling effect, and I
Yes.
didn't understand what happened caused that ceiling effect.
Oh, so the ceiling effect is caused by the measure itself. Like you can't have it's not possible to have a BMI of 120.
Okay.
Like if you look at how BMI is calculated,
Mm-hmm.
there is in fact a physical limit.
Oh, okay.
Because
Just like
of
your
height.
GPA.
Yeah. Because of, GPA is another good example.
Okay.
I mean, even with weighted GPAs, the highest you can get to 5. Like it can't go above that.
Yeah.
And so when you're dealing with correlation or when you're dealing with a fit line, which we'll get into after the midterm when we look at fitting the slope for things, you might predict people to be higher than that, but they can't be higher than that. So you have to be very careful if you have floor and ceiling effects. I do a lot of research in rheumatoid arthritis, and our main outcome there is something called the DAS28, and it goes between 0 and 10. So if I'm using it as a continuous outcome, and I get a confidence interval that goes like, it's telling me the mean's 8 and the confidence bound goes from 6 to 12, I would actually automatically cut that confidence bound off at 10 because it can't be 12.
Yes.
So that's what a floor and a ceiling effect are. And you have to be really careful when you have metrics like that have floor and ceiling effects and using them in linear models. You really have to look at the linearity and make sure it's okay. On the BMI, you tend to get a pretty good spread, but it tends to be kind of skewed. Like there tend to be a lot of people on the upper end of BMI that are shorter and way more. So they end up with large BMIs, super morbidly obese people. And then things like the DAS28 scale that I measured, if people are in very good health, you'll get a lot of zeros.
Oh, yeah.
Right. And so then you're left with this clump or this like giant line at 0. And in that case, talking about the linearity, you might actually want to, that's a situation where you would say in your data analysis, X% of people had a DAS score of 0. So 30% of our respondents were in perfect health and their arthritis wasn't affecting them and they had a DAS score of 0. And then you would move on and say, for those with a DAS score higher than 0, we fit a linear model.
Okay.
So you would exclude the zeros and you would just look at the people that had active disease. So I like the way that you think about this because you're really thinking about like the next step, which is great, which is why you might want to take more biostat classes if you're like.
I love it. This is so interesting to me. I'm taking this class and healthcare management and health behavior, which are all the core classes. And this is the most interesting class.
I love counting things. I think it's, more information for me in terms of data. I just find it fascinating.
Yes.
Are you in MPH? What's your MPH in? Are you EPI or are you health behavior?
Epi.
Okay. And is this like your last class, or are you going to be here next year?
I'm gonna be here next year. I'm an undergrad, and this is my fast grad.
Oh, you're undergrad? Fantastic.
I'm taking like one class at a time.
Yeah. Well, so let me tell you this. If you are interested in this in the fall, BST 613 is being offered.
Mm-hmm.
And this class is if you've taken this class, you can take 613. And it goes into time to event. So survival analysis, we talk about repeated measures. So we talk about if people have multiple measures over time. So if I'm like measuring blood pressure, not just once, or cholesterol, not just once, but like over time periods. And then we also talk about non-parametric analysis. So if it's not normally distributed, like these tests are robust, but there's certainly instances where we can't use them. Talk about that. And then we talk more about logistic regression in 613. So if you have a categorical outcome. So if you're interested, if you really like this, think about taking 613 in the fall. It's online and it's with me.
What? I wish it's in class. I think it would be more fun if it's in class.
Well, so for the MSPH, which is online, and the MPH is online, since it's one of the electives, it has to be offered online.
Oh, okay.
So
okay.
We don't have enough people that take the class or enough professors to teach